number 3 in the section on linear regression is dealing with carbon dioxide emissions, and we have our data, and a lot of this is on the calculator, and these are the steps which we need to follow. I want to look at part A. It says find the equation of the regression line that gives the millions of metric tons of carbon dioxide emissions y as a function of x, the number of years after 2010. And they want us to round to the thousands. So something very important here is that they want this to be the number of years after 2010. So when I'm entering in this data, I can't just enter in 2010. So 2010 would be 0 years after 2010. 2012 would be 2 years. 2014 would be 4. This would be 6. 8. 2020 would be 10 years after that. 12. 14. 16. 18, 20, and 22. So when I enter in my data, I want to make sure I enter it like this. So that is my first step, is to enter in my data. So I want to do stat, edit, and edit on my calculator. So if you press the stat button under the edit menu and the edit command, then you should enter in this data. And I've taken pictures of my calculator as I've done this. This doesn't show everything because, again, it doesn't just stop at 12, it's going to continue. So make sure that you enter in your data. Okay, and then after you enter in your data, then you want to do stat, calc, and linear regression. So if you go to stat, calc, 4 is linear regression, press enter. If you have a certain version of the calculator, you may need to go down to the bottom and press enter again on like a second menu that it gives you. But then you should be able to get to this screen here. And we're of the form y is equal to ax plus b, which is just our template for our slope-intercept form. And these are the numbers that we want to plug in there. And they want them rounded to the thousands. So if I go back and write this out, then that's going to be y is equal to 18.962x plus 321.509. So that is our regression line. So for part B, they want us to graph the data points and the regression line. So I need to do this. I need to go to y equals, I need to make sure my plot 1 is turned on, and I need to type in my equation. So if you go to y equals, make sure that your plot 1 is highlighted. If you've done the first question, then this should already be highlighted. And then you want to type in the equation into y1. Okay, and then you want to go to zoom, and you want to do zoom stat so that makes the window look at all the data points that you've entered in here. And then it should look like this. So you'll see that the line goes through almost all the dots. It's very close, so this is a very good representation of the data. So I'm basically just going to copy that. Again, we already did the zoom stat. So I'm just going to copy that here, and your picture doesn't need to be perfect as long as it's kind of roughly the right shape. Okay, so how well does the model fit the data? Comment on the correlation coefficient. So that's the R value. I mean, we can already see here that the line is very close to the dots. It's a very good representation. But let's check out the R value, because it should be pretty close to 1 or -1. In this case, we can definitely confirm that It's 0.997. So that's excellent. So R is equal to 0.997, which is very good. Again, all that is saying is that the line goes through most of the dots. The line is very close to the dots. So that means that this line that we've calculated here is a good representation, meaning if you use it to predict the future, it's probably going to be accurate. Whereas if this number were like 0.1, then it would not be a very accurate representation. Okay, so that is the regression equation and the graph. So now they're going to ask us some questions about it. So they actually want us to now use the regression equation. So part D says, what does the model predict the millions of metric tons of carbon dioxide emissions will be in 2027? Okay, when they say 2027, we need to kind of know what they're talking about. First of all, is this an X value or a Y value? Well, it's an X value because all of our years were X's. That's what we entered in the first list, so they're all X's. But it's actually not 2027. I mean, it's 2027, but it's not X is equal to 2027 because everything was typed in with regards to 2010 as the starting point. So 2027 is actually 17 years past 2010. So X is equal to 17. So that's what we're going to have to plug into our equation. So 17 is what you want to plug into your X in your regression equation. And if you type that in the calculator and round that answer to the nearest tenths, then you should get 643.9, and my label would be million metric tons. Part E says, when will the millions of metric tons of carbon dioxide emissions reach 776.6 according to the model? So according to the line that you made, what's it going to be? So the value that they give us here, is this an X value or a Y value? Well, the CO2 emissions, that was the Y value. Again, if you go back to the problem, these are our X, these are our Y's. So now let me go back. So I'm going to plug that in for Y. And then I need to solve for X. So if I subtract the 321 from both sides, and then divide both sides by 18.962, and then they also want us to round to the nearest whole number, then we should get 24. So X is equal to 24. Now, what does this mean? So this means, well, our X value is our years, and it's specifically years after 2010. So 24 years after 2010 would be 2034. This would happen. So that is our final answer. You always need to be careful with the time frame that they're asking. So this problem asked to define everything with 2010 as the starting point. Some questions may want 1900 as the starting point. Some questions may want 1990 as the starting point. Some questions may want 2000 as the starting point. So just depending on the context of the question, a lot of times they'll have different starting points that you need to be careful of.